Let's start. Hello all. Let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. Let's go with our today. And today is this one. Okay, should open. Reordered list. Given the head of a single linked list, reorder it in place by interleaving nodes from the front and the back, so the order become first, last, second, second to last, and so on. Only the nodes link may change, not the values. Okay, so 1 2 3 4 5. So this is our question. Now 1 3 4 5 and null. The answer would be first take the element from the first one. Now the last 5. Now the second 2. Now the second last 4th. Now the middle 3 and then null. So this is our answer. If you go to the last step, the result is 15243. Similarly 15243. So how could we do that? So can you see a pattern like not this one? Can you see a pattern like here, like this? Take a pointer L. This is one of our pointer L. Suppose put L here, R here. Now let's do a thing. Like first, this is our answer. So first we take L, which is nothing but 1. Okay, increase the L. Then take R, put 5, decrease the R. Now again 2, increase the L. Now take the R, which is nothing but 4. Now decrease the R to here. And then simply 3. And then null. So can we do something like here? If we just go and check. So what are we doing here? We are using 2 pointers. It's as simple. But here we have to actually make sure that we are actually interlinking this, because in some previous question we stored everything into an array and we just put everything from there. But here we have to interlink it, not like we just stored every value into a vector and then just make another list like that. Okay, so our code will be very simple. Okay, our code will be very simple. Okay, very simple. So first we are given a head. Let me write it. Okay, first we have to collect node references into a vector. Okay, collect all node and its reference into a vector. Then take L starting from 0 and R starting from n minus 1. Start and last. Then simply while L less than R. Simple logic. Append the node. Append the node L and increase the L. And when we append the node N, at the same time we have to append from the last. So append node R, the R minus minus simply. And now we have to relink in that order. Okay, so why we are doing this step? Because here clearly mentioned that it is placed by intervaling node. Okay, only node link may be changed, not the values. Okay, only node links may be changed, not the values. So this is our code or the condition. Let's run it. But its code will be much more interesting, not that simple that we get. So go to the code. So this is our pseudocode. You can easily see it here. But the code, we have given a void list. Okay. First, simply take a list of vector, simply list node type, take it v, much more easier. And but first, if the head is null or only one element, then simply return. Why? Because if there is only one null element, what do you have to do? You have to return it. If there is only one element like this, like one null, doesn't matter because this is the head. In any terms you change it, it will be like this. So now take a pointer. This is nothing but current pointing to head, and while the current is not equal to null, so just push every node into the vector and simply goes to the next step, goes to the next step. Next step. Now we have stored every value into v. Okay. Now simply take l, which is starting from 0, and also an r. Okay. And r, which is nothing but v dot size minus 1. Okay. So we are pointing one pointer to the start, another one to the end. Now we have to ensure everything, but first we are taking a a tail a tail which is nothing but null. So why we are taking this as null? Because we want to reconstruct the whole linked list. Okay, we just pick every value from the array or the vector v and we reconstruct it with this tail. Okay, so it is somehow pointing to the last element that we actually in. So when we are reconstructing, the last element we are adding is actually where when we are just at, at last we have to just go to tail, uh, like when we reconstructing, first our tail would be okay, first our tail would be here, then simply the tail goes here. So this is our approach. So tail is just point helping us to point a or insert element at the end. Okay. So we start with null, because at the starting we have nothing. Okay, simple. At the start we have nothing. So until while simply L is less than R, simple our two pointers approach. First, we have to check that we have to check for one condition, which is whenever the tail is null, it simply means that we don't reconstructed it from the we don't reconstruct it till now. So there is no head of the linked list. So see, if we got the 1 here, we can easily put 5 after this one. But when we don't get this one, we have to ensure that we have 1 at the starting. Also, the head pointing to this one. Okay. So to ensure that the head always pointing to the starting, so we have to check the condition while this. So it simply means that if the tail is null, we just take not of null, which is a true value. Okay. And it only runs when it is in the first condition or the first time. Okay, so add add simple v of l. Okay, because at the starting you have to insert the l element. Okay, you have to insert the l or the first element, so add it here and point the head to tail. Simple. But if if it is not, like we already have the one here, now we only have to ensure we have to ensure that we enter 5 in a good location. Okay, okay. So for that we are going to this else condition, where simple the tail next is going to simple v of l plus plus. Okay, plus we increase it by 1. Okay, and tail goes to next element. We only for the first time when the tail is null, and it only take the first element and make it as a head. Okay, so this else statement will run rest of the time, but we have to take the l also the r. So if the it takes the first element, now it has to take the last element. Okay, so it's simply tail next equal to v of r minus minus, and tail equal to tail next. Okay, so what does this if else statement do? The left part or the l part, and this statement do the right part or the r part. Okay, now one time occurs like when there is a element are odd, like the l goes to here, the r goes to here. Okay, in this case the loop breaks. Okay, we have to break it to ensure that there will no copy, because if we put a equal to here, then it put this and again put this three, because both of the pointer into a same condition. So for that, at the end we have to check one condition. If l is equal to r, then simply add into the next, simply v of l, no need to increase anything, and tail goes to tail next, tail goes to tail next, and at the end we have to do a line which is simply tail next equal to null. Why at the end we need a tail next equal to null? Okay, we are, let's see it, we are actually reconstructing every element. Okay, reconstructing every link of the element. So when we are reconstructing every element length, so suppose, okay, the 4 points to 3, but what the 3 points to? In the original list, the 3 points to 4, but what we need this one. We need this one, but we have this one. Okay, so we need a null pointer, but we got this only. This is not a linked list, this is something a loop here, because you can say here, because at the end when you push the 3, we don't check that there is anything or not, and our tail is actually now here, tail is actually at the end. So at the end we have to make sure the last element always pointing to a null. So for that, because the 3 is pointing to 4 in this linked list, that we just stored every or total value of a node with proper value and address into that node. So the condition of this tail would become this, but we want this, so we ensure that at the end we do this to put the last element pointing to null, which is a single linked list property. Let's run it. Okay, spelling mistake. Another page. Okay, it's working. Submitting it. Yes, yes, yes. It works. And yeah, this is the code. And This is take a big O of n space and big O of n time. As simple as that. Now, in our optimize approach, so here the time let's see, the time complexity is big O of n, and also the space complexity is big O of n. Now the matter is that we are now need to optimize this to big O of 1. Have to optimize it to big O of 1. Okay. So how actually we can optimize it? Very simple. We have to use some of our previous concepts. Okay. So here, how actually we do this two pointer like stuff? We can do this two pointer like stuff because we store everything into an array, and linked list doesn't, the singly linked list doesn't have the previous element link. Okay, so this 3 doesn't have this 2 link. Okay, this link is not possible in a singly linked list. So we have to ensure that the link is possible. How? Let's see it. So this is our linked list. If what is the middle? This 3 is the middle. Take pointer and do this. What if we do this? Okay, but the 3 is still point to 4, and we also have to ensure that the 3 points to the null. Okay, so this is our middle, simply the middle. Now, and suppose this is our tail. We take the first head, then the tail. Simply take the tail here, or take the head here first. Uh, take it. So we take the first our head like this. Take the head first. So 1. Increase our head to here. Tail. Take 5 here. Decrease our tail to here. Okay. So now the head 2. Increase our head to this mid. Tail 4 goes to this null. Okay. Rather than pointing this 3 towards null, what we can do is we just put the 4 towards null. It will be much more easier. Okay. So now this pointing towards null. Okay, so now tail is here. Now put the head, the 3. Okay, and simply 3 points to null. So what we do, we first find out our mid, then we reverse rest of the mid. Actually did something like that in like palindrome. Let me open it. Let me open it. Yeah, see it. First we calculate the mid in the palindrome, then simply reverse the mid and check from every element like the reverse head or the head to do palindrome. So here we take two heads like a head which is at the starting and a reverse head. Same we'll do here. Same. So what is our pseudocode look like? This one. Let's write our pseudocode. So we are given a head. Simply find the mid of the of linked list. Then simply reverse the rest of mid. Reverse the rest of mid and simply L pointing to front and R pointing to reverse back. Okay, then put all the nodes in order of L plus plus, then simply R minus minus, and at the end simply return our head. So let's evaluate it. Yes, we did it. And our pseudocode is this. Very simple, huh? But everyone. Okay, I will do some copy paste from here, and if any problem regarding this mid or the reverse, the links will be in the description to the original videos where the link so the reverse and the mid finding actually used. Okay, so first what we have to ensure, we have to find our mid. We have to find our mid. So take like find mid and head. And what is the efficient way to find a find mid? It is the slow and fast pointer approach. And our slow and fast pointer approach is this. Our slow and fast pointer is this. Video link will be in the description. So check it out if you don't understand it, because we are using 2 pointers here. One do one step, another do two step. So we reach the, when the fast pointer which take two step is reaching the end, reach the end, then simply the slow pointer is our middle point. Okay. Now, reverse. And which part we have to reverse? See, we have to reverse. Our mid is 3. And which part we have to reverse? 4 to 5. What is 4? What is 4 in this linked list? The next of 3. So first, A, and let's just copy it, which is nothing but reverse, reverse, or take it as R, because it returns the last index, which is actually our R. So it returns the R. So simply do one thing. Reverse the mid next. Okay. And what is mid next? Mid next is simply this 4. Okay, so from this 4 till the end we have to reverse this part. And this is our reverse logic using 3 pointers approach. We previously did it. Link will be in the description. Check it out, because we are using 3 pointers to get the. And now what this 4 pointing to? This 4 is actually pointing to this 5, because after this 3 pointing to this 4, so after reverse actually our linked list will become 1 2 3, then 4. Okay, then simply 5. And what happened? This 4 still goes to 5, so we have to reduce this link. So when we have to reduce this link, we have to make sure that we put this link to another simple approach. Okay, so we have to do that. So for that, do a simple thing. What is this 4? It is simply the mid next, because the mid is this 3. So it is simply till now it is the mid next, and put the mid next to null. Okay, now everything is fine. Now take a list node, and which is nothing but L, which is nothing but head, which is nothing but a head. So we just take our head here. So while R, until any element in the reverse possible. Why? Because simple, we need to ensure our list. Okay, so if somehow we reach this place and we somehow complete it and our tail goes to here now, or our R goes to here and our L is here. So the next step is always because this L next is always 3. So we don't have to check this this linked list. Huh? We have to check that this portion is available or not. Simple. So for that, while the R is present and do take some temporary note, like take temporary one, take it like it is nothing but it is simply nothing but L next, and take another one which is temporary 2, which is nothing but R next. Okay, now L next is pointing to R and R next is pointing to temporary one. Okay, now the L goes to temporary 1 and the R goes to temporary 2. What I am doing here, I just write 6 line. So what we actually did, let's do it here also. So this is the point, this is the R, this is the L. We take temporary one, like let's take T1 here and temporary 2 here. Okay, simple. Next, but before, let's first run it and check it that it is okay or not. It is okay, let's submit it. Yes, it's working. Now goes to the question. Our next, okay, so we put our next pointer here. T1 is temporary one, for T2 is temporary 2. Okay, we put 2 pointers here, which is the next pointer. Now the L next, this pointer goes to this 5 and remove this part. See, 1 pointing to 5. Okay, now what is the next step? The R next is pointing to temporary 1. Okay, so this R, which is what is 5. So the 5 next point to temporary 1, which is 2, and just remove this element. Simple. Now 152. What is our answer? 152. Check. We got till here. Now in the next step, what we are doing, we just increase our L and R. So simply our R will become this. So now this one is our R and this one is our L. So just remove all of this and this one become our L. Which is happening. Now goes to next. So this is our temporary one and this is our temporary 2. Okay. So this is our both of the temporary one and temporary 2. Now L next is goes to R. So the L next, this 2 now goes to this R. Let me do it here. The 2 now goes to this R and just remove this. And the R next goes to this one. The R next goes to this temporary. See here. The R next goes to temporary. Okay. And now we just remove this link. Okay. Now simply change everything. So now this temporary 2 become the R. So it become the R. And this temporary 1 become the L. So just remove this temporary one, it become the L and remove this L. Now what is R pointing? R pointing to this null and the 3 pointing to 4 and and at the end we have to point this L towards this R. As simple as that. And it just do it automatically how it does it, because it goes to temporary here, temporary one, and it doesn't have any temporary, so it put to another null pointer, temporary to, and we just put everything here to here. Okay, as simple as that. So after all of this, just to ensure that we get this 1 5 2 and then 3 and then simply null. Okay, let's submit it again and check it. So this loop just goes every time pointing to everything. Okay, goes every time pointing to everything and point everything and ensure we have a perfect reordered linked list. Okay, for this to function, check the descriptions. And this is our simple while loop logic, and here we are taking just big O of n time and no extra space, so the time complexity would become big and space complexity will become big O of 1. Yeah, this is the one. Go check out this video, use this link to get a 7-day free trial. This link to get a 7-day free trial, use this platform by dsa.chaicode.com. Thank you very much.